Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in today's video, I am going to discuss the solutions of two mathematics questions that were asked in recently held JEE Advanced 2025 exam. Now this is the first question. This question is based on the topic of trigonometry. It says let alpha equal to 1 upon sine 60 degree into sine 61 degree plus 1 upon sine 62 degree into sine 63 degree plus and so on till plus 1 upon sine 118 degree into sine 119 degree. Then the value of cosecant 1 degree divided upon alpha whole square is. Now students, to solve this question, I am writing alpha equal to, on the right hand side, I am multiplying and dividing all the terms by sine 1 degree. So now it becomes 1 upon sine 1 degree into inside the bracket. The first term will become sine 1 degree divided upon sine 60 degree into sine 61 degree. Now instead of writing numerator as sine 1 degree, I will write it as sine of 61 degree minus 60 degree. Right? And in the denominator we have sine 60 degree into sine 61 degree. Now why I am doing this? Because when I use the identity of sine A minus B, which is equal to sine A cos B minus cos A sine B, then you can clearly notice that we will be able to express this term as the difference of two terms, and we will be able to remove the product of two terms in the denominator. So it will eventually help us to find the sum of all these terms. Now students, the second term becomes sine of 63 degree minus 62 degree whole divided upon sine 62 degree into sine 63 degree plus and so on till plus the last term is sine of 119 degree minus 118 degree whole divided upon sine of 119 degree into sine of 118 degree. Now students, we move further. Now students, alpha is equal to cosecant 1 degree into inside the bracket the first term is sine of 61 degree minus 60 degree whole divided upon sine 60 degree into sine 61 degree. Now when we use the formula of sine A minus B in the numerator and separate the terms, then we get cot 60 degree minus cot 61 degree. Similarly, for the second term, we get cot 62 degree minus cot 63 degree. It will keep on going like this till plus cot 118 degree minus cot 119 degree. Now students, I can write alpha upon cosecant 1 degree equal to. Now on the right hand side, I am dividing these terms into two groups. The first group contains cot 60 degree minus cot 61 degree plus cot 62 degree minus cot 63 degree and so on till plus cot 90 degree. Now students, After cot 90 degree, another group of terms starts. And from this group, I am taking out minus common. And inside the bracket, I get cot 91 degree minus cot 92 degree plus cot 93 degree and so on till minus cot 118 degree plus cot 119 degree. Right? Now students, we move further. Now students, alpha upon cosecant 1 degree becomes equal to, now in the first group, we have cot 60 degree minus cot 61 degree plus cot 62 degree minus cot 63 degree plus and so on till minus cot 89 degree plus cot 90 degree. Now students, cot 90 degree is 0. So there is no need to write it. Now minus inside the bracket in the second group, we have cot 91 degree. Now cot 91 degree can be written as cot of 180 degree minus 89 degree. And we know that cot of 180 degree minus theta is minus cot theta. So that means cot of 91 degree is actually minus cot 89 degree. Fine. And similarly, minus cot 92 degree will become equal to plus cot 88 degree. And so on. That means the next term is going to be minus cot 87 degree plus cot 86 degree and so on till the last term of this group is plus cot 119 degree, which is actually cot of 180 minus 61 degree. And this is nothing but minus cot 61 degree. Fine. Now students, you can clearly see that all the terms in these two groups will cancel each other except cot 60 degree. So that means we are just left with cot 60 degree on the right hand side. And cot 60 degree is 1 upon root 3. So that means I can write cosecant 1 degree upon alpha whole square equal to 3. So students, 3 is the correct answer of this question. Now we move to the next question. Now students, this is the second question of this video. It's a nice problem on definite integrals. It says if alpha equal to integral 1 upon 2 to 2 tan inverse x dx whole divided upon 2x square minus 3x plus 2, then the value of root 7 into tan of 2 alpha into root 7 whole divided upon pi is. Here the inverse trigonometric function tan inverse x assumes values in open interval minus pi by 2 to pi by 2. Now students, let's start with the given integral alpha, and it is equal to integral 1 upon 2 to 2 tan inverse x dx whole divided upon 2x square minus 3x plus 2. Now students, to solve this integral, I am doing a substitution, and that is I am putting t equal to 1 upon x. So that means dt will become equal to minus 1 upon x square into dx. Right? Now students, alpha becomes equal to, now since we have done substitution, so obviously we will have to change the limits of the integral. Now in place of 1 upon 2, it will become 2, and in place of 2, it will become 1 upon 2. Now the entire integral will get converted in terms of t. So tan inverse x will now become equal to tan inverse 1 upon t, and dx will become equal to minus x square dt, which further becomes equal to minus dt upon t square. So I am taking out minus common outside, and inside it is dt upon t square, and in the denominator 2x square minus 3x plus 2 can be written as 2 upon t square minus 3 upon t plus 2, because we have replaced x by 1 upon t. Now students, it further becomes equal to, just use the basic property of definite integral, and that is integral a to b fx dx is equal to minus integral b to a fx dx. Right? So now the minus sign will go away and the limits of the integral will get interchanged. So in place of 2, now it is 1 upon 2, and in place of 1 upon 2, now it is 2. Now students, tan inverse 1 upon t can be written as cot inverse t and into dt, whole divided upon, in the denominator, now it is 2t square minus 3t plus 2. Now students, we move further. Now students, we know that name of variable does not affect the value of the definite integral. So that means now alpha can be written equal to integral 1 upon 2 to 2 cot inverse x dx whole divided upon 2x square minus 3x plus 2. I am calling this as equation number 2, and originally we had alpha equal to integral 1 upon 2 to 2 tan inverse x dx whole divided upon 2x square minus 3x plus 2. I am calling this as equation number 1. Now students, add both of these equations. So when you add them, you get 2 alpha equal to integral 1 upon 2 to 2. Now in the numerator, we will have tan inverse x plus cot inverse x, which is nothing but pi upon 2 into dx whole divided upon, it is 2x square minus 3x plus 2. Now students, alpha becomes equal to pi upon 4 into integral 1 upon 2 to 2 dx upon 2x square minus 3x plus 2. Now the question has become easier to solve. Now alpha becomes equal to pi upon 8 into integral 1 upon 2 to 2 dx upon x square minus 3x upon 2 plus 1. I have taken out 2 common from the denominator. Now students, we move further and find the value of alpha. Now students, alpha can further be written as pi upon 8 into integral 1 upon 2 to 2 dx upon, now x square minus 3x upon 2 plus 1 can further be written as x minus 3 upon 4 whole square plus 1 minus 9 upon 16, right? Now alpha becomes equal to pi upon 8 into integral 1 upon 2 to 2 dx upon x minus 3 upon 4 whole square plus 7 upon 16. Now 7 upon 16 can be written as root 7 upon 4 whole square. Now students, we can easily find the value of alpha by using the appropriate formula. And now alpha is equal to pi upon 8 into, inside the bracket it is going to be 4 upon root 7 into tan inverse of 4x minus 3 whole divided upon root 7. And this value is under the limits 1 upon 2 to 2. Now alpha becomes equal to pi upon 8 into, now 4 upon root 7 you can take out common, into, inside the bracket tan inverse of 4x minus 3 whole divided upon root 7, and this value is under the limits 1 upon 2 to 2. Now students, this finally becomes equal to alpha equal to pi upon 2 root 7 into, now when we put x as 2, it becomes tan inverse of 5 upon root 7 minus, now when we put x as 1 upon 2, it becomes tan inverse of minus 1 upon root 7, and the bracket is closed. Now students, alpha becomes equal to pi upon 2 root 7 into, inside the bracket tan inverse of 5 upon root 7 plus tan inverse of 1 upon root 7, because tan inverse of minus x is equal to minus tan inverse x. Now students, I will use the formula of tan inverse x plus tan inverse y, which is equal to tan inverse x plus y upon 1 minus xy. So now alpha becomes equal to pi upon 2 root 7 into, inside the bracket it is going to be tan inverse of 5 upon root 7 plus 1 upon root 7, which is 6 upon root 7, whole divided upon 1 minus 5 upon 7, which is 2 upon 7. Now students, we move further. Now students, alpha is equal to pi upon 2 root 7 into tan inverse of 3 root 7. So that means 2 into root 7 into alpha whole divided upon pi can be written as tan inverse of 3 root 7. Or I can write tan of 2 root 7 into alpha whole divided upon pi equal to 3 root 7. So that means the value of root 7 into tan of 2 root 7 into alpha whole divided upon pi is equal to 3 into 7, which is finally 21. So students, 21 is the correct answer of this question. Now students, very soon I will be posting videos that will give you the solutions of other questions from JEE Advanced 2025 mathematics paper. So keep watching my videos and enhance your knowledge of mathematics. Thanks.